In this recording, we're going to start out our stats unit by learning how to describe distributions using center, spread, and shape. So, first off, we need some data. In this case, we're going to use the points scored by the 2017-2018 State Championship JD girls basketball team. Okay, so they had 29 games. And when you look at all those numbers, your eyes can kind of glaze over, but you also can see some stuff. You can kind of quickly, because they're sorted, see the minimum and the max and get a sense of sort of what's a typical score. We're going to get beyond just what is the average, because that obviously doesn't describe that many of these scores. We're also going to talk about how the spread could be described by something called standard deviation. So let's go back and look at this introductory paragraph real quick. In this case, we have a set of objects or subjects that share a common characteristic that is being studied. Okay, so that is the population. Okay, most of the time the entire population is not measured. It's just not practical, right? We can't take all the fish out of Onondaga Lake in order to find out characteristics of fish in Onondaga Lake. So instead we take a sample, and then we can infer characteristics about that population. Okay, so as it says, still all populations in theory have a population parameter that describe the population. Its mean, its standard deviation, which you'll learn about, and its interquartile range, which is something you learned about in algebra. Okay? So populations have population parameters. Samples have sample statistics. So if I were to inquire about the population parameters of fish in Onondaga Lake, I couldn't get them all, so I might take some samples of fish and then get some sample statistics. Okay. In this case, we have the entire population. This is all their games. I'm not just taking a sample of their games, because 29 is a manageable number and I happen to have access to it. Okay, so I want you to start out by making a dot plot. If you know how to do it, good. It was something you learned in Algebra 1. If you don't, then you'll learn in a second. So I'd like you to pause, see if you can make a dot plot of the data. If you want to watch a little bit and see if if you're on the right track, if it is something that you remember, that's fine too. And then play the recording when you're ready. Okay, so hopefully you took time to pause and work this out on your own, or here's a little hint. I'm going to start at 31, make a point. Start at 35. Okay, so I'm plotting dots approximately where their point would be. So if you didn't get started on that because you were nervous, you weren't sure if you had it, pause now, do yours, and then play the recording. Okay, so there you have your dot plot, and we can see just the general trend. We can see that it was rare for them to score less than 40 points or so. It was common for them to score, in the 60s and 70s. Okay. But again, our minds can't take in all those numbers, so instead we like population parameters or sample statistics, summary numbers. Okay, so we're now going to use our calculator to determine these summary statistics, the mean, the median, the standard deviation of both the sample and population. Okay, so let's grab our calculator. I'll refresh you for those steps if you forgot. You might want to jot them down. You can pause the video and write them down. So first we're going to go to Stat, which is right here. You're going to go into Edit because you don't have the data in there to be able to analyze. If you already had some numbers, like say it was 9, 6, 3, you already had some numbers in there you want to clear out, you simply bring your cursor up on top of the heading, hit Clear, Enter, and now that's cleared. If you accidentally deleted your column, I'll just hit delete. Oh shoot, where's L2? Well, it's nowhere, right? It's gone. It can come back. What you do is you go to Stat, Setup Editor, choice 5, and then hit Enter, and that will restore your list. So now again, hit Stat, Edit, you've got your list. Okay, so you're going to want to enter that data into your calculator and play the recording when you're ready. Okay, one thing to check is that your last number was entered into the 29th row. Remember, when we go back to our data, oftentimes the number of data points will be stated. So you have 29 here, and that checks out. We've got 29 in our last row. Good. It's important to double check. You're going to be frustrated, and I was trying to be careful. Hopefully I didn't make any mistakes entering that data. You're going to be frustrated if you get it wrong because you have a typo. So it's good just to double check. Cool. So now we're going to hit Stat. We've got our data entered, so we're going to go to Calc. So right click, and we want one variable stats. We're never going to use two variable stats. It's always one variable stats when we're doing our descriptive statistics. Okay, so hit enter, and it asks you, is your list in L1? Yes. Do you have a frequency list? We do not. It's important that this is blank. That will mess you up. So if it has it has anything there, just clear it out, and then cursor down to calculate, hit enter, and our summary statistics are displayed. I'm going to take a screenshot, put it into our notes. Good. So there's some information here. In fact, there's even more information down below. If you were to scroll down in your screen, you'll see further, because of that arrow that was pointing down, you'll see that there's more information. So let's just go over the easy stuff first. N29, I think you can figure out what that stands for. It's 29 data points. The minimum and the maximum, those are easy. Median is your middle number. Okay, so if we were to arrange these in order, which they are, the middle number would be 64. Q1, your first quartile. That's the halfway point of the first half of the data. Kind of think of like if it was a school year. All right, mid-year is your median. End of the first quarter, in statistics we call it the first quartile. That's your 54.5. And your end of your third quarter, or your halfway point of the second half, is a 75. All right. So we've got our data, and you can see it on your screen. And so we're going to now answer these questions. What are the values requested here? So the mean, first off, okay, that's this number right here. That X with a bar above it, that refers to the mean of the sample. Okay, so we call it X bar, and that's when we're speaking about the sample. Well, in this case, the sample is going to be the same as the population, so the mean is the same. Okay, so that turned out to be 62.8. We'll just round to the nearest tenth. That's arbitrary, but that's what I'm going to use here. Oh, it actually does say in my notes, my directions. Cool. Next, so that's checked off. And now let's just have a look. Is that sort of the balance point? If I were to put my little balance point right there at 62.5-ish, does it look like it would balance this data? If these were like pennies laid out on a yardstick, and this is the fulcrum, the balance point, would it balance? And I think it would. There are some really low values, but there aren't very many of them. And so even though, kind of like think about a teeter-totter, like when you're a seesaw, when you're younger, if you weren't as heavy as your older sibling and you sat further out, you could balance them. So these lower points, because they're further out, even though there's not very many of them, they balance out some of these weightier numbers. All right, next, median. We've got that. So your median, we said, was 64. Just put that down here with a different color. And feel free to make notes for yourself about balance point and median being the middle number, about when they're arranged in order. Let's write something further here. There is also something called the population mean, and it has its own symbol. It does not show up here. So it's called mu. All right, mu. Kind of looks like an M where the left side of the M is a little longer. All right, and that's a Greek letter mu. And that's your population mean. Okay, so if I had two different values, let's say I had all the fish in the lake have a particular mean for weight, and I have a sample I would indicate that it's a sample, not the whole population's mean, with this symbol. Whereas I do have the whole population, so I can use either one of these. They're the same. Okay. So let's get into the standard deviation. So standard deviation is a measure of how spread out the data are. All right. So you have two of them stated here. The sample standard deviation is this one. So that's SX. And the population standard deviation is this one. This is a lowercase sigma. Okay, so sigma x. Okay. So our sigma value, our population standard deviation, we're going to round and call that 14.3. And our sample standard deviation, if this were just a sample that we were using, would be slightly bigger. It's always going to be just slightly bigger. Now that's a conversation, that explanation is going to be sort of beyond what I'm going to get into right now. But you can see the standard deviations are pretty close. Let's just see what that looks like. We'll see it actually a little bit further down in part D. But what is a standard deviation? It's a typical distance from the mean. So when I ask you to interpret this population standard deviation in context, you would say something like this. Typically, the team scored within 14.3 points, I'm getting that from right here, of the mean. Okay? That does not mean every score was within 14.3. Clearly it's not, but it's typical. Okay, so if that is a big number, think about what that tells you versus if I took another team or another year of JD's play, if they had a smaller standard deviation, what would that mean about their consistency? So think on that. Say I had another team that still averaged 62.8, but their standard deviation was 5. What would that mean about their consistency? Hopefully you realize that's going to mean they're more consistent. The numbers are grouped closer to each other. Doesn't mean they're a better or worse team. Just means they're, because they have the same average, right? Just means they're more consistent. Okay, so let's do a little thing at the bottom here to look at the percent of scores that are within 1 standard deviation and then within 2 standard deviations. So what we're going to do is we're going to take our mu, our population mean, which, what did we say it was, 62.8. And then if we're going out 1 standard deviation, that means 1 above and 1 below. Okay, within. It means 1 above and 1 below. So I've got like mu plus 1 population standard deviation. And then below, mu minus 1 population standard deviation. You might be saying, well, why am I using the population here? Well, because I know the whole population, right? I know this is the whole population. It's not just a sample that we're utilizing in order to make an inference about the greater population. So what I do is I add on and I take away by that amount. And we said that amount was 14.3. I'll scroll up a little bit so you can see. Where's that number coming from again? It's right here. It's that standard deviation of the population. So do that math. I think you get 77.1. And then to go down by 14.3, you're going to get 48.5. So if I just call that round numbers, I'm going to call that 49. I'm going to call that 77. Let's just mark approximately where those would be on our graph. So 49 is like right there. 77 right about there. And so what we're saying is typically the scores are within 1 standard deviation. There are some that are outside, right? But typically they are. It would not be typical to say that the mark was way out here, because that does not describe a typical score. Okay. It also asks us to go out 2 standard deviations. So let's do that. Again, we're going to go mu plus 2 standard deviations now. All right, I know I'm introducing a lot of symbols here, so we're going to add on another 14.3. And then U minus 2 standard deviations. That should be, I apologize. All right, so take away again 14.3. So if you do that quick math, you're going to get 34.2. That number minus 14.3. Do this one on your own, then play the recording when you're ready. What's that figure right there? Okay, so hopefully you got that it was 91.4. Okay, so it asks you furthermore, what are the percents? What are the percents within those? Well, between 48.5 and 77.1, well, that is excluding 1, 2, 3, 4, 5. It excludes those. Then 77.1, well, those 5 are outside. Okay, so 9 of these scores are beyond. That means 20 of the scores are within this range, right? 20 of the scores are between my red bars. I guess I just could have counted my dots, right? It would have worked as well. So 20 out of 29. If you do that math, it works out to be approximately 69% are within 1 standard deviation of the mean. I just wrote SD. Okay, I want you on your own to figure out how many scores are between 34.2 and 91.4 and make a percentage out of that. Play the recording when you're ready. Okay, so hopefully you paused and did that work on your own. That's the whole point of these videos. You got to do some work on your own. Well, there's only one score that's outside of those figures, right? It's just this one. So there's only one. That means 28 are inside. So that should have given you a 28 over 29. When you make that into a percent, to the nearest percent, right, it said, nearest percent, that gives us 97%. So practically everything is within 2 standard deviations. That's kind of what I expected. Being a person that studied a little statistics, I expected about 2/3 of the numbers to be within 1 standard deviation, and almost all of them, somewhere around 95 to 97%, to be within 2 standard deviations. Cool. Thanks for watching.